Now, yes, you have a question.
So why is the dorsal root ganglion and not ventral root ganglion?
Yes, very interesting question. She is saying why there is dorsal root ganglion and why there is no ventral root ganglion. One answer is very simple, other is the embryological answer. I will give the both. Simple answer is that there are no cell bodies in ventral root. So how there can be ganglion? Because you see the fibers which are in ventral root, their cell bodies are in ventral gray horn. The cell bodies are here and they are just fibers here, right? So there is no collection of cell bodies in the ventral root, so there is no ganglion here. Here, because there are collection of cell bodies. Now you must be thinking, why collection of cell bodies are here, why not here? Answer is that when neural tube was developing embryologically, some of the fibers of the neural tube detached and they made neural crest cells. Neural crest cells. Some of those neural crest cells converted into pseudo unipolar cells which connected on one side to the spinal cord, on other side to the periphery to the receptors present in the sclerotome, right? That is why they are outside. So exact to the point, cerebral cortex hitting answer should be that dorsal root ganglion is developed from the what? Neural tube derived crest cells. You just imagine my hands, neural tube is developed just only as a neural tube. But look at my thumbs. My thumbs grow separately, right? And then these thumbs detach and come on the side. So remaining part of my hand, both hands make a neural tube, and thumb's neural tissue on both sides become separate, and this is called neural crest cell. Some of these neural crest cells make the pseudo-unipolar neurons, and even some of these neural crest cells spread in the body, they participate in making sympathetic ganglion, parasympathetic ganglion, and many other cells which I will not discuss right now, so that you don't derive me into some other area of medical science. So you understand what is this here? Dorsal root ganglion. So they have central connection, right? And they are having peripheral connection. Now some of these are heavily myelinated. Some of these fibers are heavily myelinated. For example, fibers which are called A alpha type. Now remember, here the motor fibers which were heavily myelinated, alpha motor neuron, they were also heavily myelinated. So they were also called A alpha. So A alpha fibers, axons, are heavily myelinated. It means they are very rapidly transmitting information transmitting fibers. A alpha, heavily myelinated with lot of nodes of Ranvier, actually are fast conducting fibers, right? Here alpha motor neurons are more myelinated, fast conducting. Gamma motor neurons are less myelinated, relatively slow conducting, and these visceromotor neuron, or we can say here sympathetic fibers, are relatively less myelinated. But when we go to the dorsal neurons, here also some are heavily myelinated, some are less myelinated, some are not myelinated. I have started discussion with most heavily myelinated fibers. Now here you should understand one thing. When I say a fiber is myelinated or not myelinated, what is the real difference? The real difference is, if this is a neuron, right? This is neuron, and let's suppose this green cell is Schwann cell. A Schwann cell wraps around it many times, right? Wraps around it many times. It makes a thick, and of course there should be somewhere its nucleus also. Now this green cell, just like that, this is my axon, and I take another cell and wrap it around multiple times. and it make a big fatty layer. So this situation is called myelinated fibers. This is called myelinated fibers. But sometimes what happens, Schwann cell is here and this is one Schwann cell. It just covers, what is this? Axon. But its processes do not wrap around it, right? So we can say from here it is going like that. So when situation is like this, we say unmyelinated fibers. Many of the times medical persons are confused. They think myelinated mean there are Schwann cells, and they think wrongly that unmyelinated means there are no Schwann cells. But in reality, if this is an axon and this is embedded in a Schwann cell, right? But Schwann cell is not wrapping around it, then it is unmyelinated. So unmyelinated fibers do have Schwann cell, but we can say they are well supported by the Schwann cells, but they are not multiple times wrapped by the layers of the Schwann cell membrane. But if this is another, what is this? No, this is my middle finger. But anyway, let's imagine this is axon, and around it the Schwann cell which wraps and wraps and wraps and wraps, right, very tightly. Then what we will say that this axon is heavily myelinated. So why I wanted to give you this concept, because the fibers which are taking information, sensory information from peripheral body parts of the body through the dorsal ramus and ventral ramus, right? For example, this is a sensory fiber which is connected to, suppose, Pacinian corpuscle. You know, they are concerned with sensations, or Merkel's corpuscle, or free nerve endings. Okay, so these are sensory fibers going. Now these sensory fibers will actually go to the posterior root. In the same way, sensory fibers from here, the skin, there are some receptors, they come from here, dorsal root, they also go to the posterior root and eventually connected to the central nervous system. Exactly what happens to them in spinal cord, I will not discuss now, because I've discussed in detail in neuroanatomy lectures. But what I really want to highlight, that purpose of dorsal root is that it should connect the sensory fibers from which are taking information, sensory information from the sensory receptors. Sensory fibers taking sensory information from the sensory receptors present in one sclerotome, right? These all sensations, right, going through as action potential through these fibers, these sensory fibers are entering into spinal cord through its dorsal door or back door or dorsal root, dorsal spinal root, posterior spinal root, or we call it sensory root. And it has a swelling, and that swelling is called dorsal root ganglion, which is having which type of neurons? Unipolar neuron, which are derived from neural crest cells. Very good, I'm impressed. Now, let's talk about these fibers. You know, some of the sensations are very fast and some of the sensations are slow. I will give you a classical example. For example, in very cold weather in winter, you go to take shower. Of course, you will undress, right? You undress and you're happy and you're singing, and then you open the tap. Unfortunately, water which come was very hot. First you will feel the water, and then you will feel it is hot, and then you will jump away. Now, why you feel water first? That is fine touch. And just with milliseconds, you feel it's hot, very hot, super hot, and you jump away. Why you feel the thermal sensation later? Because they are coming with less myelinated fibers. They are coming with less myelinated fibers. But the water touch was coming with heavily myelinated fibers. That is why same water has watery feeling, which you feel, of course, for me, your hair may protect you, but for me, it's a little more terrible situation. But this hot waterfall, the watery feeling will come first. But before I start enjoying it by my central cortical processing, oh my God, the thermal feeling will come over there. And then I have to jump out of the water stream. Let's hope there's a space for jumping, right? And then I will, of course, put the tap off, and then I will shout to the person who was responsible to keep my geyser on, or what happened, or maybe I will curse myself. I don't know. It depends on the real situation, right? But what I'm trying to say, that sensations which are collected, they are entering in the spinal cord, for example, from my hand. That is why, when you become more intelligent and when you go to new place, if you are a wise man, you open the tap, first you put a little hand under it to feel that how much water is cold or hot, right? So you don't need to jump, you just pull your hand away, right? Anyway, so sense of cold or heat, right? Hot, no, heat, thermal sensations, they travel through unmyelinated fibers, which are called C fibers. But sense of touch, fine touch especially, there are two types of touch, right? One is fine touch, other touch I will talk about. Fine touch sensations go through fast, heavily myelinated fibers, right? That is why watery sensation go through fast fibers, right? And following are the thermal sensations, very cold water or very hot water, right? And after that, some reflexes come into action. Now, let's come into these fibers. These fibers, if these are heavily myelinated, we call them alpha 1 A alpha fiber. A alpha fiber, please don't confuse it with alpha motor fibers. Alpha motor and gamma motor fibers are in anterior root, right? And because alpha motor fibers are heavily myelinated, they are also called A alpha fiber. But when A is there, it means we are talking about myelination. So A alpha are heavily myelinated. Usually they are taking the sensations of fine touch, sensations of 2-point discrimination, right? They are having sensations of fine touch, 2-point discrimination, light pressure, and vibration. They are going very rapidly through A alpha fibers, which are heavily myelinated. Then there are fibers which are moderately myelinated or relatively less myelinated, suppose A beta or A delta. Let's talk about A beta. The A beta are also taking some, okay, I think I've made a mistake. You need to excuse me. This is not A alpha. These fibers, A alpha was here. These are A beta, right? Now, what I want to say, that proprioception fibers are A alpha, motor fibers are A alpha, right? Proprioception fibers are A alpha. If you insist that Dr. Najeeb, you write here A alpha, now I want you keep it A alpha, then I will change my sentence in a way that heavily myelinated A alpha bring incoming proprioceptive fibers, which are the fastest fiber in the sensory system. But A alpha fiber in the motor system are for extrafusal fibers. Do I need to repeat or you understand it? Alhamdulillah, you understand it. Now, A alpha, then come A beta. Actually, A beta fibers are relatively less myelinated, right? So their conduction velocity will be less. They will bring sensations of fine touch, 2-point discrimination, light touch, light pressure, and vibration, right? So again, A alpha sensory, here A alpha motor. A alpha sensory, just remember one word, proprioception. Proprioception is what? Sensations coming from locomotor system which help you to understand the position of your any part of the body without looking at that, right? So their fastest is A alpha. They should be fast because when you are walking, proprioception is helping you which leg is forward, which leg is backward, which is on the ground, and which you are going to take off the ground. I fear if you don't have such fibers so fast, maybe you take both legs from the ground, and that can be end up into tragedy when you are walking, right? So A alpha, fast proprioception, helps you to integrate your walking and other fast movement. Then A beta, fine touch, light pressure and vibration. Then comes fibers which are not myelinated. We call them C fiber. What we call them?
C fibers.
C fiber. C fibers, they are like this. They are having Schwann cells, but they are not well wrapped by Schwann cells. They are very slow. What is this? They are very slow conducting fibers. These fibers take pain and temperature and crude touch. Don't tell gross touch. Gross touch has many meanings, right? So call it crude touch. Now, what is the real difference in fine touch and crude touch? Fine touch is when someone put a pin and you can exactly tell where it is pointing on your skin. Then fibers are A beta. But if someone put hand on your back, it's very, very exact point you cannot tell, right? Or someone put a finger on your back, right? And then he removes and you try to locate that area, you might locate it little up or down, right? Because that is not taken by fast fibers, that is by slow fibers. So if someone is lightly caressing you, these are C fibers. But if someone give a slap, what are these fibers? A and C both. A sharp touch and C pain, right? Anyway, so what I'm saying, dorsal root is connecting the spinal cord at dorsolateral sulcus, right, with the spinal nerve proper by fusing motor root, right? Dorsal root has a ganglion which has what kind of cells? Pseudo-unipolar cells. And they have multiple type of fibers with different myelination which are having different velocities and carrying different modality of sensations. The fibers which they are carrying, right, the central process are connected to the spinal cord, peripheral process move through the posterior root to the spinal nerve process proper, and then they enter into what? Dorsal ramus, and others enter into ventral ramus. Dorsal ramus will supply the muscles and skin on the back, and ventral rami will supply the body wall, anterolateral body wall, and your limbs, right? That is why to supply the limbs, there is brachial plexus, or for lower limb there is sacral plexus. They are made of ventral rami. So ventral rami are for anterolateral part of the body and limbs attached with them, and dorsal rami just for the back. Ventral root purely motor, dorsal root purely sensory. What is this? Spinal nerve process mixed nerve, because of motor and sensory, and even visceromotor and viscerosensory, which we will discuss next time. And dorsal ramus and ventral ramus, they are also mixed, right? And what I was saying, again it's worth repeating, and dorsal root is attached to the spinal cord at dorsolateral sulcus. Ventral root is attached with anterolateral sulcus, and ventral root has three types of fibers. What are these fibers? Alpha motor neurons for extrafusal muscle cells, gamma motor neurons which are for intrafusal muscle cells, and they have autonomic or visceromotor fibers, right, or autonomic motor fibers or sympathetic fibers in this specific case, T6. Dorsal root also have many type of fibers, but before that you should mention pseudo-unipolar cells. Then you must mention some fibers are fast conducting, some fibers are slow conducting. Fast conducting are heavily myelinated, like A alpha fiber for proprioception, A beta fiber for fine touch or proprioception was A alpha, and this is for light touch or fine touch or light pressure or vibration. And then there were C fibers which were for crude touch and also for pain and temperature. And they do have also viscerosensory fiber, which we will discuss in next lecture. In detail, visceromotor fiber, how, where they go, what are dorsal, what is this? What are white rami, what are gray rami, we will discuss next time. Today our discussion was only this, that ventral root is motor, dorsal root is sensory, both of them are connected with, they are connected with the spinal cord, both of them move laterally at intervertebral foramen, almost around that place, they fuse with each other and they give rise to a mixed nerve, which is typical spinal nerve or classical spinal nerve, or we can say or spinal nerve proper, and it gives one very important branch which goes recurrent. It is called recurrent meningeal branch, which will go back to the vertebral column and supply the vertebra and periosteum and dura mater, will not supply arachnoid matter and pia mater. Arachnoid matter and pia mater do not have pain receptors. So this recurrent, what is this recurrent? Meningeal. This is recurrent meningeal, not recurrent laryngeal, right? This recurrent meningeal will supply, if you forget all supply, at least remember dura mater, right? So again, different fibers, but all fibers have their cell bodies here. All fibers have central process and peripheral process. Peripheral process connected with the receptors and bringing different types of sensations, and different fibers have different velocity of conduction, right, because of different degree of myelination. In simple way, we can say anterior root from spinal cord and posterior root from spinal cord move laterally, they fuse together, make spinal nerve proper, and spinal nerve proper is a very short nerve, usually 1 to 2 centimeter, and then it rapidly divides into dorsal ramus and ventral ramus. Dorsal ramus supplies the back muscles and back skin, and ventral ramus supplies the anterolateral body muscles and limbs muscles and anterolateral body sensations and skin and sensations coming from the limbs, right? And what about these visceral fibers or autonomic fibers, and why one is called white rami, what is other is called gray rami, and so why some are ascending, why some are descending, so why some are splanchnic nerves? This is what we are going to discuss next. Thank you very much.